So in this particular video, I want to talk a little bit about how to use my Molar map to solve my problems and solve my questions. So on here, I kind of draw a little bit how the Molar map looks like, and you probably have one in your book. So just look for the one in your book. But, well, actually we don't have this connection here. Basically, I will have a particular problem giving me, I don't know, the grams of my compound A and ask me to find something in B or particles of B, particles of A, and I can walk through the Molar map. So let me show you two examples, and these two examples will be really helpful to understand how the Molar map works. So on here, I have ethane, and my questions say that it was a combustion reaction with ethane. And when it says combustion, I need to remember that combustion reactions, we have oxygen in my reactant side making CO2 plus H2O. Organic compound, when sulfur combustion, we have O2 in a reactant side plus CO2 plus H2O. Do I need to know these three elements and compounds? Yes, I need. Every time it says it is organic compound suffering combustion, I need to remember that it is O2, CO2, and H2O. My next step now, well, it says that it was 500 of ethane that burned, and asking me how much of water was produced. Okay? So first of all, before I go into the question and use my Molar map, I need to balance my equation. So here I have carbon, hydrogen, and oxygen. The product side, I have carbon, hydrogen, and oxygen. I have 2 carbons in this side, and I have 1 carbon in the other side. I have 6 hydrogens in this side and 2 hydrogens in the other side. And I have 2 oxygens in this side, and I have 3 in the other side. Because oxygen is by itself, I'd leave it to be balanced the least. So I know that I have 2 carbons, and I'm going to start with carbons. I'm going to place a 2 here. So now I have 2 carbons and 2 carbons. And I'm balancing carbons. However, when I put a 2 here, I'm not only changing the number of carbons in my molecule, but I also change the number of oxygens. Now it's 2 times 2 is 4, plus 1, 5. Now I have 5 hydrogens. Now I go for oxygens. Now I go for hydrogens. I have 6 hydrogens in this side and 2 in this side. So I will place a 3 here. 2 times 3 gives me a 6. So I'm also balanced with my hydrogens. The problem is, now that I place a 3 here, I also change the number of oxygen. So I have 4, 2 times 2 plus 3, I have a 7. So now how do I make this to a 7? Well, in order to do that, I can do 2 times 7 halves, because 2 and 2 cancel out and I ended up with a 7. So we place a 7.5 here. However, we don't like fractions in our coefficients. So in order to take this fraction, send this fraction away, I will multiply the whole equation by 2. Okay? If I do that, I have now a 2 here, because 2 times 1 gives me a 2. 2 and 2 will cancel out, so I ended up with a 7. 2 times 2 gives me a 4. And 2 times 3 gives me a 6. So now I don't have the fraction, and my equation is balanced. Now that I have my equation balanced, I can use the Molar map to figure it out. How much water was produced when 500 of ethane sulfur decomposition. So I start with the 500 grams of ethane. And now I look at my molar map and I say, well, the question gives me the mass of ethane. So I'm here. Ethane is my compound A, and I have the grams. So I'm here. And the question wants me to find the mass of water produced. So the question is asking me to find the mass of my compound B. In order to find the mass of my compound B, in the case that is water, I first need to find how many moles I have in that grams using my molar mass. And then I need to use my balance equation, the ratio, the mole ratio, to find the moles of B. And from there, I'm going to use the molar mass again to find the moles here. Let me write here, molar mass. Okay? So I start with this, and I say, well, I needed the molar mass to find the moles. So because I wanted the moles goes in the top. And grams of ethane goes in the bottom. Because then grams you cancel out with grams. I already calculated the molar mass of C2H6 and it is 30.069. So doing that divided by that gives me the moles. The next step, I need to find the moles of B. In order to find the moles of B, I use the balanced equation that I balanced before, and this is why I need to balance before I just start the question, and use the mole ratio. So in this case here, moles of C2H6 goes in the bottom because I can cancel them out. And I want to find the mass of the moles of B, which is water. So moles of water. And I just look at my equation, 2 and 6. So 6 moles of water, 2 moles of ethane. The next and last step is using the molar mass. Now the molar mass of my compound B, because now I have B moles, to find the mass of B that is produced. Because moles of B is in the top, I write moles of B in the bottom. And here goes the molar mass of B, that in this case is water. And I already calculated that particular molar mass and I put it on here. It's 18.0153 grams of H2O. So grams and grams cancel, moles and moles cancel, moles and moles cancel. And I ended up with grams of H2O. So in order to find how much grams of water was produced, I needed to do 500 times 6 times 18.0153 divided by 30.069 times 2 times 1. I already did the calculation and the final answer was 899 grams of water. So when I'm using my molar mass, my molar map, to find out something there, first I need to say, well, I have my equation, it is balanced, good. Now I look at it and say 500 grams of H2C6. I'm here, the question is asking me to find the mass of B in the case of water, so I need to get in there. So in order to do this, I just follow the lines. If the question is asking me to find the particles of B. I would do mass, moles of A, balance equation, and then go here using Avogadro's number. So look at your molar map, say I'm here and I need to find this particular part, and just follow the molar